In this video, we're going to look at some new identities. We're going to look at the sum and difference identities for cosine. In the next video, we'll look at sum and difference identities for tangent. We just have them broken up a little bit here. Again, the idea of an identity is it is a statement of equivalence that's always true. So it allows us to rewrite or make substitutions in different expressions to help us evaluate them. So we have our two formulas for the sum and difference identities for cosine. Cosine of a plus b is equal to cosine of a times cosine of b minus sine of a sine of b. Notice the change in the signs there. Cosine of a minus b is equal to cosine of a cosine of b plus sine a sine of b. Again, notice the change in the signs. Now, the reason we have these identities, again, is to substitute in new versions so that we can evaluate trig functions easier. If I look at the examples I have right here, cosine of 15 degrees, cosine of 7 pi over 12, the directions ask for an exact value of each expression. An exact value means you are not using a calculator, meaning you need to figure out this value or know this value using the unit circle. But looking at those angles, 15 degrees, 7 pi over 12, neither of those are angles on the unit circle. So we have these identities, and the ones we're working with today are the sum and difference identities. We'll learn about double angle identities, half angle identities that can also be used to evaluate trig function values for angles that are not on the unit circle. So to evaluate cosine of 15 degrees, and this is, again, we're assuming we're going to use these sum and difference identities. It's not that you couldn't use other identities, we just haven't learned them yet. So at this point, this is what we're going to be working with, is those sum and difference identities at the top of the page. So cosine of 15 degrees, what we're trying to figure out are two angles from the unit circle that would either add or subtract to give me 15 degrees. Now there's more than one possible combination. We're going to try to use the easiest combination, which are values from the first quadrant, but that's not always going to be an option. But in this case, 15 degrees could be written as cosine of 45 degrees minus 30 degrees. So 45 is going to be my A. 30 is going to be my B. Since this is a difference, we're using that second formula, which tells me that this is equal to cosine of A, which is our 45 degrees, times cosine of B, or 30 degrees, plus sine of 45 degrees times sine of 30 degrees. Now, how you derive these values of cosine 45, cosine of 30 degrees, sine 45, sine of 30 degrees, you can derive them if you've watched my video on how to derive values from the unit circle. I'm going to kind of sketch this on the side of my page here. You might just have the unit circle memorized. You might be referencing the unit circle. The obvious preference would be that you do not always have to reference your unit circle to get those values. This is going to be primarily true if you're taking a course where you don't have access to that. So having some techniques that don't necessarily require a regular reference is good. So 45 degrees, that's going to be in my first quadrant. That perfect diagonal, I know that ordered pair is going to be the square root of 2 over 2, square root of 2 over 2. And then for 30 degrees is pi over 6, or that smaller section. So I've got that kind of flatter triangle, which shows that the x is going to be my larger value, so square root of 3 over 2. And the y is the smaller value, 1/2. Now I like to have the entire ordered pair written down because I do need both sine and cosine values for both of these. Remember, cosine is our x, sine is our y. Cosine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Plus sine of 45 degrees is square root of 2 over 2 times sine of 30 degrees is 1/2. Simplifying further, the square root of 2 times the square root of 3 is the square root of 6 over 4 plus square root of 2 over 4, which we can combine those, the square root of 6 plus the square root of 2 divided by 4. And that's the exact value for cosine of 15 degrees. All right, cosine of 7 pi over 12. This one's a little bit trickier. I think that fractions, if you're not really comfortable with fractions, it's a little bit harder to work with them. You could opt to convert to degrees. That's just going to be an extra step. I think having practice and working with those fractions and getting better with that is really the best option, especially for those of you who are moving on to that calc sequence. So I'm thinking of two numbers that will add up to 7 pi over 12. Really, what we just need to think about is what two numbers add up to 7? So I'm going to use 3 pi over 12 plus 4 pi over 12. Now, before I keep going, I know that those two fractions add to 7 pi over 12, but what I want to think about is, are those values, are those two fractions, are they going to simplify to something on the unit circle? Because if they don't, then they're not helpful. 6 pi over 12 and 1 pi over 12 would also give me 7 pi over 12, but 1 pi over 12 is not on our unit circle. So it's not a useful separation of that 7 pi over 12. So 3 pi over 12, that's going to simplify to pi over 4. So that looks good. And 4 pi over 12 is going to simplify to pi over 3. So yeah, these two values add up nicely and give me values from my unit circle. All right, so we've got our A, we've got our B. A is pi over 4, B is pi over 3. Since this is the sum formula for cosine, this is going to be cosine of A, pi over 4, times cosine of B, pi over 3, minus sine of pi over 4, times sine of pi over 3. All right, so I'm going to do my sketch to derive those trig function values. Pi over 4 is in our first quadrant. That ordered pair is square root of 2 over 2, square root of 2 over 2. And then pi over 3 is that larger, it's 60 degrees, so it's that larger angle, creating a more tall triangle. From here, I can see my x is the shorter leg, my y is the longer leg, so that ordered pair is going to be 1/2 square root of 3 over 2. All right, so cosine of pi over 4, square root of 2 over 2, cosine of pi over 3, 1/2. Plus sine of pi over 4 is square root of 2 over 2 times sine of pi over 3, square root of 3 over 2. Square root of 2 over 4 plus the square root of 6 over 4. Since they have the same denominator, we can combine the two fractions, the square root of 2 plus the square root of 6 over 4. Cosine of 87 degrees, cosine of 93 degrees, minus sine of 87 degrees, sine of 93 degrees. Both of these angles, 87 degrees, 93 degrees, not angles that we can evaluate with exact values because they're not on the unit circle. So what we want to try to do is observe whether or not this expression can be represented in another way. We've been working with finding cosine of the sum of two angles and expanding it. In this example, we have that expanded form and we want to rewrite it as the sum or difference of two angles. Since we're dealing with a minus sign in C, that means this is going to be the sum of two angles, cosine of A plus B. So this can be written as cosine of 87 degrees plus 93 degrees. We add 87 and 93. This is cosine of 180 degrees. That's one of those quadrantal angles. 180 degrees is that negative x-axis, that ordered pair being -1, 0. Cosine is the x-coordinate, so this is equal to -1. Back in, I believe it was in Unit 1, we learned about some cofunction identities, these relationships between two trig functions, cosine and sine are cofunctions. That just said that the sine of one angle is equal to cosine of its complement. So now we are going to verify this. Thinking about what we've done in previous videos of verifying a trig identity, we want to manipulate one side to make it look like the other side. So we're going to use our difference formula, because we have minus here, for cosine. We're going to manipulate the left-hand side to see if we can get it equal to sine of x. So we've got cosine of 90 minus x. Here's our a, here's our b. Using that difference formula, this is cosine of 90 degrees, cosine of x, plus sine of 90 degrees, sine of x. And we want to verify that this is equal to sine of x. Our 90 degrees, that's our positive y-axis. That ordered pair is 0, 1. Cosine of 90 degrees is 0. Sine of 90 degrees is 1. We simplify. 0 times cosine of x is 0. 1 times sine of x is sine of x. So using the difference identity for cosine, we have now verified that cofunction identity. Suppose that A and B are angles in standard position, such that sine of A is -5/13, and sine of B is 4/5. We know A is in quadrant 4 and B is in quadrant 2. Find each of the following. Cosine of A plus B and cosine of A minus B. Now we can start by just expanding using our sum and difference formulas. Cosine of A plus B is cosine of A cosine of B minus sine of A sine of B. Cosine of A minus B is cosine of A cosine of B plus sine of A sine of B. Now looking at the information given, we have sine of A. We also have sine of B, but we don't have cosine of A or cosine of B. So we're going to have to do some work to figure out what those other trig function values are. This is where we're going to use the information that A is in quadrant 4, B is in quadrant 2. So we're going to have to draw some pictures over here in our margin. Angle A is in quadrant 4, so I'm going to emphasize quadrant 4. I'm just sketching this, so it doesn't really matter where you draw that terminal side. You're just trying to set up your picture. So here's our angle A, and sine of A is -5/13. We want to recall that sine is equal to opposite over hypotenuse. So this is my -5. My hypotenuse is 13. To find the missing leg of this triangle, or that x-coordinate, we're going to use the Pythagorean theorem. 13 squared equals -5 squared plus, that's going to be our x value squared. 13 squared is 169 equals 25 plus x squared. X squared is equal to 144. And then we take the square root of both sides. Now here's where we want to be careful of the sign. Since we're in the fourth quadrant, x is going to be positive. So that leg length is 12. Now we also want to do the same thing for angle B. I have to make this one a little bit smaller. They say angle B is in quadrant 2, so let me redraw my coordinate system to emphasize quadrant 2. Here's my angle B. And we're given that sine of B is 4/5. When we're in the second quadrant, the y value is positive. So that's why sine is going to be positive. So that vertical leg is 4, the hypotenuse is 5. 25 is equal to 16 plus x squared. Subtracting 16 from both sides, we get 9. So 9 is equal to x squared. And now here again, thinking about what quadrant and so what sign we're going to use. Because if we take the square root of 9, we actually get plus or minus 3, but we only have one length here. And because we're in the second quadrant, that x is going to be negative. So we want this to be -3. So now we have our two triangles, which then we can derive both sine and cosine of these two angles. So let's look at A, cosine of A plus B. We need cosine of A. Looking at that triangle for A, cosine is adjacent over hypotenuse, so that's going to be 12 over 13. And cosine of B, again, adjacent over hypotenuse is going to be -3 over 5. Minus sine of A. Looking at my triangle, sine of A is opposite over hypotenuse, so -5 over 13. I'm going to start using parentheses when we're subtracting negatives. We want to make sure we add some parentheses. And really, it doesn't hurt to have parentheses around all of these values. And then sine of B, opposite over hypotenuse is 5, 4 over 5. Now we are given both sine of A and sine of B in the problem, so you could have just substituted it there. You didn't necessarily need to reference that triangle that we just drew. All right, simplifying. 12 times -3 is -36. 13 times 5 is 65. Minus -5 times 4, -20 over 13 times 5 is 65. When we subtract a negative, that's the same as addition. So we have -36 plus 20 over 65, -16 over 65 is our final answer. Cosine of A, cosine of B, plus sine of A, sine of B for example B. Cosine of angle A, which we could reference back to what we have here. Or again, you can look at your picture. It really depends on what you've already done, what work you've already done. Cosine of A is going to be -12 over 13. It's not negative. Cosine of B is -3/5. Plus sine of A is -5 over 13. And sine of B is 4 over 5. So our two terms are going to simplify the same way. -36 over 65 plus -20 over 65. When we're adding a negative, that's the same as subtraction. So this is -36 minus 20 over 65, or -56 over 65.